Many gearboxes have a clutch to protect the components. This video is for a friction clutch on a Servis Rhino shredder. I show how it works, how to repair, and how to adjust. The section on adjustment without disassembly is located at the end of the video.
So let's talk about observations and how we can tell if we've got a problem. First of all, yesterday when I was operating this, you'll see that there's a lot of dark, actually this is smoke. The friction discs in here were burning up, and unfortunately there's no good way to tell whether the input coming in is being transferred into the gearbox unless you see these friction discs, which are actually like brake pads, burning up. And that's what's happening to me yesterday. So I'm going to replace these. So because I know that right now, in fact, just with regular mowing, this thing is slipping, and it's just burning these discs up. So let's take a look at what we are looking for here. So power comes through here. It goes through this yoke and into this plate. Then this plate has a friction disc right here and a friction disc right here. There's two steel plates here, which are part of the shaft system that goes into the gearbox. So all of this up here, so we have right here, we have these Bellevue discs. There's two of them in here, which actually, as this compresses against here, this provides force to press against this plate, which presses this friction disc, which then contacts, and so there's friction between this drive plate here and the shaft plate. Okay, so I've got some replacement discs here. These happen to be OEM. I went to the store and he had two kinds. As you'll see, it looks like a lining on a brake. And so he had two offers here. One was OEM, and looking at it, I could actually see metallic in the lining, which gave me some confidence anyway that this is more of a metallic pad. There are, as you're familiar with brakes, there's ceramic, there's organic, there's semi-metallic, there's metallic, and I'm hoping that this is metallic and it provides plenty of friction, but with that safety of being able to avoid breakage if there's something happened to my blades and it jammed it up. So if we take a look at what we've got here, so this is, it looks like it's about an eighth or slightly more than an eighth inch thick right here, and we compare that against what we have in here. There is, let's see if I can line that up, there is wear. And so this plate, although we have a plate in here, this plate has been showing some wear because it's thinner than what the OEM plate is. Okay, can you see that? Let's see if I can line this up so that you can tell. Okay, so it's not half, but it's probably about 60% of what OEM plate is. So that's what we're looking for. They might not be totally missing or gone. If they are, you're in trouble, because there's absolutely no way that this input power is going to be transferred into the shaft, and that's when you have it spinning freely. Also, there's a big nut in here. Make sure you put some penetrant on that so that it'll come off easily. All right, there's a big thread here, right here. So apply some penetrant to that before you get going. Here's a hint that things might not be very good here. You see, this plate is going to turn with the PTO shaft. This system here including this plate, is a steel, and friction disc. This steel and all of this here is going to turn with the mower cutter. So this is the cutting unit. This is the power. So power comes in, transfers through the friction disc into the shaft here, system here, that rotates for your mower. So here's the hint. You take a look at this friction disc that's after this plate and after that, behind here or before here. If you see anything like this where the disc, you see it's flush right here, it's actually indented here, but it swells out here, that means that disc is broken, and you're going to be missing parts, which will reduce the available friction for it. Not good. So to let you know, one of the tools that I use for this, you'll see I've got a big pipe wrench here because we have to go over this diameter here. You see that this is a big 36-incher. I bought this years ago, but fortunately I can get this thing big enough to be able to fit around that piece there, which I'm going to use to unscrew this ring, maintenance ring, which presses against that. So I needed 2 hands in order to use my pipe wrench and loosen this up. But right now I've got it loose enough to where he'll turn. Anyway, so I'm going to take that off. So you should be able to see that what I've got is it's starting to loosen up. There's now some space in between these. So this, what looks like a double, and for this manufacturer is actually, this is a one piece, and this is the part that I need to loosen up. This is the part that is threaded onto here, and I need to unthread it in order to take all these other pieces off. Okay, so I think it's all coming off by hand now. All right, so there we are. This is all it's threaded, and that's that part there. Then we have these 2 Bellevue washers. You see they're concave. You look at it that way, so they're not flat washers. And those are what apply, they're springs. Those are what apply pressure against this whole system here. And then next we have, there we go. Then we have a plate, and just like a disc brake, we have our braking surface. We have the plate. We can see that it's chewed up around the edge there, not good. And the center doesn't fit, so it's had better days. And you see here, see this plate here has teeth in it for this. I call it a large spline. But so this is the shaft that goes into the gearbox. This plate is going to be on driving that shaft, as well as the plate that's behind here. And now we have, this is the drive plate, which again looks like a disc brake on both sides. And then we have another friction disc, and this one has material to it. Could be that it wore enough that it's not tight anymore. If you're scraping for money, I guess one thing you could do is periodically adjust or tighten up this this ring right here and apply more force as some of that material is worn away, especially if you ever have a situation where something has caused it to start to slip, starts to wear some of these friction discs, and you know that some of them have been worn away, you need to reapply pressure so that you have the proper pressure or enough pressure to keep it from slipping, because the looser it gets, the more easily it'll slip. You could even be mowing in heavy grass or heavy material and it'll be slipping all the time, which means it's just wearing. And it's not driving the input shaft at the same speed that your power is going into that, so it's just going to wear it out. Okay, assembly time. First of all, I did what I could to clean up some of the debris that was in here, because you want it to be able to move and slide properly. So first thing I do is put on a new friction disc. It should fit with no looseness in there. Then I'm going to put on my I'll call it my drive plate, and so that goes on. There's a little bit of looseness there. We'll deal with that a little bit. Then we put on another friction plate. No looseness there. Then we put on this plate here, which is my secondary shaft plate. And then we put on the Bellevue washers. And then finally we're going to put on this collar to tighten her back up. There we go. Yeah, the two of them came apart, which is expected. It's kind of what I've expected in the beginning. Alright, so that'll go on. And then this screw collar to do final tightening. And that will go on. Okay, I'm going to do that off camera. So it's what I call hand tight, finger tight right now. So what I ended up doing is that since this plate would not center itself perfectly, what I did was I felt, if I rotated it so that it's horizontal, the wings are horizontal like this, I made sure that the spacing on the top and spacing on the bottom felt to be the same. I moved it back and forth, tried to make sure it was centered that way. So in other words, I'm trying to get it as centered as possible, because in theory, once I put this this yoke back on and it fits on this shaft and I bolt it together, that everything, then this should become aligned, but it's not going to be aligned since I have to tighten it up right now before this collar is put on, and I can't tighten up and get it ready until while the I can't do it while the yoke is on. Anyway, that's the way I'm doing it. So just to let you know, this is what I did, was I tried to center it so that I wouldn't have an issue when it came to putting these blocks back on and bolting to here, so that it tries to get itself centered. Okay, so I've got it on here, and I tightened it up some with my pipe wrench. I did not flatten this washer out. As you can see, this Bellevue washer needs to have some arch to it so that it can actually act as a spring. But I got this tightened down enough so that it does apply good pressure against there, and periodically I should do that. Now, then the next thing is put these 3 bolts in here, which would do a final press and set the tension, proper tension on the Bellevue washer, so that it continues to operate and apply pressure on that friction plate, the 2 friction discs, the way they should be. Okay, these 3 bolts are in, and I tightened them up some. I did not tighten them up to the shoulder because my gaps were starting to vary between where the bolt was and where the bolt wasn't, which means that this disc in here that's applying pressure against the washers has some deflection, and so I didn't want to continue to deflect that any more than it's supposed to be. Okay, I've got my yoke in place, so I take the washer, put that on. So you can see what I'm doing. Put the nut on, sorry, the washer on. Put the nut on. Okay, and for these, I'll put a washer on, and then a lock washer, another, and I'm going to use my blue, and I'm going to then put the nuts on those. One more tip, this yoke is not going to rotate very easily. The shaft will rotate before it's all connected together. So when you do that, and this goes back to actually this plate here, when you put that plate in and you determine the rotation, try to make that the wings on the plate perpendicular to the hole in the shaft. All right, because when it comes time to putting this collar on, this yoke on, you want to make sure that, let's see if I can show you. There, you can see a little bit of daylight down there. You want to make sure that that hole is aligned up so that you'll be able to put a cotter pin, or you'll be able to put something in to secure this castle nut when you get to this point here. If you're unfortunate, you're going to find that it's going to be perpendicular to your point of view, and it's going to be impossible to put any kind of cotter pin in there. Okay, one more final tip about finishing this up. I have got my castle nut in place here. I've got my hole lined up. I tightened it up by hand. I did not apply a lot of pressure, and I didn't want to. So the reason is because this yoke is going to be pressing. See, I've got a little bit of gap here, right? I've got a little bit of the gap, so that shaft comes in and it comes up to here. And I do not want to cause this yoke to be pressed up and friction against this. The reason is because this yoke is designed, supposed to, rotate on that shaft. So I do not want to stop that through friction of tightening this nut. I do want it tight, and let's put it this way. I want it to be very firm in order to hold it in place, but what happens if you over tighten that, you'll be putting stress on the yoke, you'll be putting pressure on this, you'll be putting pressure on your plate here, and causing a lot of stress, and maybe even bend or break this, and causing more friction that it's designed to use. So the friction should only be in the plates. It should not be up here between the yoke and the shaft. So don't over tighten it. That's the message. Don't over tighten. If you get it secured, then back it off a little bit, put a pin in there, and just leave it at that. Here's something you might want to consider on these plates that are sliding up against or friction against the friction disc. You might want to consider doing something to rough them up. Maybe you use sandpaper, maybe you use a grinder, but you don't grind away material, you just create a little bit more friction. In other words, some very, very fine scratches to help that friction disc grab and hold on for what it is. Anyway, that's just a consideration you might want to think about doing if you continue to have problems in terms of power delivery to the blades. So how do you do some maintenance to make sure everything is tight without having to replace these discs or take everything apart? Here's what I did on this one. This is my third one. So the first two I replaced the discs because I just felt it needed to be done. So this one here, the plates, friction plates, the friction discs look okay. What I did was I went and loosened 3 of these nuts, and then I had to try to spin this collar. And the way I did that was I loosened up the bolt to where I felt it wasn't going to be touching this next ring here. And then, here we are. I just put that thing on there in the proper direction, and I used another piece of wood as the whole idea. In other words, I used the bolts as leverage to try to get it to rotate, because this has some marks in here, but I don't have a tool to grab those and try to rotate it. So I did it by using the bolt and the bolt head. But you don't want to back it out any more than necessary, because you don't want to be snapping that bolt off, of course. And so that's what I did, was I did that, and then I was able to tighten it up just a little bit, probably only about that much in terms of distance, but I felt it was enough, and then I went ahead and tightened these bolts down. So I know that this one is got the pressure that it needs to be able to hold those friction discs from sliding on the plates. So that's one tip that you can use without taking it all apart, part of your maintenance program.